High-voltage electricity poses significant dangers, and awareness of these risks is crucial for anyone working with or around electrical systems. However, it's important to balance the need for safety education with ethical considerations, particularly respecting an individual's privacy and dignity. Sharing graphic images of injuries, especially without the explicit consent of the person involved, can be deeply unethical and harmful. It can cause further distress to the injured person and their family, and it can violate their right to privacy. Furthermore, such images can be desensitizing and may not be the most effective way to promote safety. A more responsible approach to electrical safety training focuses on providing clear, factual information about the hazards involved, demonstrating safe work practices, and emphasizing the importance of following established safety protocols. This includes understanding concepts like voltage, current, resistance, and power, as well as the specific dangers associated with high-voltage systems. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It's the force that pushes electrons through a conductor. Current is the flow of electrical charge measured in amps. It's the rate at which electrons are flowing. Resistance is the opposition to the flow of current measured in ohms. It impedes the flow of electrons. Power is the rate at which electrical energy is transferred or used, measured in watts. It's the product of voltage and current. Understanding these basic concepts is essential for comprehending how electricity works and how it can be dangerous. High-voltage systems present several specific hazards. Firstly, there's the risk of electric shock, which occurs when a person comes into contact with a live conductor and provides a path for current to flow through their body. The severity of an electric shock depends on several factors, including the voltage, the amount of current flowing through the body, the duration of the exposure, and the path the current takes through the body. Even relatively low voltage shocks can be dangerous, especially if the current passes through the heart or brain. Secondly, there's the risk of arc flash, which is a sudden release of electrical energy in the form of heat and light. Arc flashes can occur when there is a short circuit or other fault in an electrical system. The temperatures generated by an arc flash can be extremely high, reaching tens of thousands of degrees Fahrenheit, and can cause severe burns, blindness, and even death. Thirdly, there's the risk of arc blast, which is the pressure wave created by an arc flash. Arc blasts can be powerful enough to knock people off their feet, damage equipment, and even cause structural damage to buildings. In addition to these direct hazards, high-voltage systems can also create indirect hazards. For example, the electromagnetic fields generated by high-voltage lines can interfere with electronic equipment, and the noise produced by transformers can be disruptive. To protect against these hazards, it's essential to follow established safety protocols and use appropriate personal protective equipment, or PPE. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. Insulated gloves protect against electric shock by providing a barrier between the worker's hands and live conductors. Safety glasses protect against arc flash and other eye hazards. Arc-rated clothing protects against burns from arc flash. In addition to PPE, it's also important to use safe work practices when working with or around high-voltage systems. These practices include energizing equipment before working on it, using lockout-tagout procedures to prevent accidental re-energization, maintaining safe distances from energized equipment, and using insulated tools. De-energizing equipment involves disconnecting it from the power source and verifying that it is no longer energized. Lockout-tagout procedures are used to ensure that equipment remains de-energized while it is being worked on. These procedures involve placing a lock and a tag on the disconnect switch to prevent it from being turned back on. Maintaining safe distances from energized equipment is important to prevent accidental contact with live conductors. The specific safe distance depends on the voltage of the equipment. Insulated tools are used to prevent electric shock when working on or around energized equipment. These tools have handles that are made of non-conductive materials. Proper grounding is also crucial for electrical safety. Grounding provides a low resistance path for current to flow back to the source in the event of a fault. This helps to prevent electric shock and arc flash. Grounding systems should be properly installed and maintained to ensure their effectiveness. Regular inspections and maintenance of electrical equipment are also essential for preventing accidents. Inspections should be performed by qualified personnel and should include checking for damaged or worn components, loose connections, and other potential hazards. Maintenance should include cleaning equipment, tightening connections, and replacing damaged components. Moreover, training is a vital component of electrical safety. Workers who work with or around high-voltage systems should receive comprehensive training on the hazards involved, safe work practices, and the proper use of PPE. Training should be provided by qualified instructors and should be updated regularly to reflect changes in technology and safety standards. It is also important to foster a safety culture in the workplace. This involves creating an environment where safety is valued and prioritized, and where workers are encouraged to report hazards and near misses. A strong safety culture can help to prevent accidents and injuries. In addition to these general safety principles, there are also specific regulations and standards that apply to electrical work. The National Electrical Code, or NEC, is a widely adopted standard that provides guidelines for the safe installation of electrical systems. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical systems. Other relevant standards include those developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide guidance on specific aspects of electrical safety, such as arc flash hazard analysis and electrical safety in the workplace. For example, NFPA 70E provides guidance on electrical safety in the workplace, including requirements for arc flash hazard assessments, PPE, and safe work practices. Article 130.5c in NFPA 70E covers the arc flash hazard assessment, stating it shall be performed before a person approaches exposed energized electrical conductors or circuit parts operating at 50 volts or more. This assessment determines the incident energy, which is the amount of energy that a worker could be exposed to in the event of an arc flash. Based on the incident energy, the appropriate PPE can be selected. Article 130.7c15 covers personal protective equipment for arc flash protection, stating that employees shall wear protective clothing and other PPE in accordance with the incident energy level. This includes arc-rated clothing, face shields, and gloves. Article 110.3b covers the use of equipment, stating that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This means that electrical equipment should be installed and used according to the manufacturer's instructions. Specific NEC articles also address safety requirements. NEC Article 110.16, for example, discusses arc flash hazard warning labels. It states that electrical equipment likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked with a warning label containing specific information about potential arc flash hazards. This labeling helps to alert workers to the potential dangers. NEC Article 230.95 covers ground fault protection for services. It requires ground fault protection for alternating current services of 1000 amps or more operating at more than 150 volts to ground, but not exceeding 1000 volts. Ground fault protection helps to prevent electrical fires and electric shock. NEC Article 430.102 covers disconnecting means for motors. It requires that each motor have a disconnecting means that is readily accessible and capable of being locked in the open position. This allows workers to safely de-energize the motor before performing maintenance. NEC Article 440.14 covers disconnecting means for air conditioning and refrigerating equipment. It requires that such equipment have a disconnecting means that is readily accessible and located within sight from the equipment. This allows workers to quickly de-energize the equipment in the event of an emergency. Electrical safety also extends to the general public. It's important to be aware of the dangers of electricity in everyday life, such as downed power lines and electrical hazards in the home. Downed power lines should be treated as if they are live and should be avoided. Contact the utility company to report downed power lines. Electrical hazards in the home include overloaded circuits, frayed wires, and damaged appliances. These hazards can be prevented by following basic electrical safety rules, such as not overloading circuits, replacing frayed wires, and unplugging appliances when they are not in use. Ground fault circuit interrupters, or GFCIs, are an important safety device that can help to prevent electric shock in the home. GFCIs are designed to detect ground faults and quickly shut off the power to the circuit. GFCIs should be installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or RFCIs, are another important safety device that can help to prevent electrical fires in the home. RFCIs are designed to detect arc faults and quickly shut off the power to the circuit. RFCIs should be installed in bedrooms and other areas where there is a risk of electrical fires. In addition to these specific safety measures, it's also important to promote a general awareness of electrical safety. This can be done through public education campaigns, training programs, and other initiatives. By raising awareness of the dangers of electricity and promoting safe practices, we can help to prevent accidents and injuries. Effective electrical safety training programs should incorporate several key elements. Firstly, they should provide a thorough understanding of electrical theory, including concepts such as voltage, current, resistance, power, and grounding. Secondly, they should cover the specific hazards associated with different types of electrical equipment and systems. Thirdly, they should teach safe work practices, such as de-energizing equipment, using lockout-tagout procedures, and maintaining safe distances. Fourthly, they should emphasize the importance of using appropriate PPE. Fifthly, they should include hands-on training, where workers can practice safe work practices under the supervision of qualified instructors. Sixthly, they should be regularly updated to reflect changes in technology and safety standards. Finally, they should be tailored to the specific needs of the workers being trained. Effective electrical safety training programs should also use a variety of teaching methods such as lectures, demonstrations, videos, and simulations. These methods can help to engage workers and make the training more effective. It is also important to assess the effectiveness of electrical safety training programs. This can be done through tests, quizzes, and observations of workers performing electrical tasks. The results of these assessments can be used to identify areas where the training program can be improved. Ultimately, the goal of electrical safety training is to create a workforce that is knowledgeable about electrical hazards, skilled in safe work practices, and committed to preventing accidents and injuries. This requires a comprehensive and ongoing effort that involves employers, employees, and safety professionals. By working together, we can create a safer working environment for everyone. Furthermore, it's important to remember that electrical safety is not just a set of rules and procedures, it's a mindset. It requires a constant awareness of the potential hazards and a commitment to taking the necessary precautions to prevent accidents. This mindset should be fostered at all levels of an organization, from senior management to front-line workers. Employers should provide the resources and support necessary to ensure that workers have the knowledge, skills, and equipment they need to work safely. Employees should take responsibility for their own safety and the safety of others. Safety professionals should provide guidance and expertise to help organizations create and maintain a safe working environment. By embracing a safety mindset, we can create a culture of safety that helps to prevent accidents and injuries. In addition to the technical aspects of electrical safety, it's also important to consider the human factors involved. Human error is a significant cause of electrical accidents. Factors such as fatigue, stress, distraction, and complacency can all contribute to human error. To mitigate the risk of human error, it's important to address these factors. This can be done through measures such as providing adequate rest breaks, reducing stress levels, minimizing distractions, and promoting a culture of vigilance. It's also important to encourage workers to speak up if they have concerns about safety. Workers should feel comfortable reporting hazards and near misses without fear of reprisal. This can help to identify potential problems before they lead to accidents. By addressing the human factors involved, we can reduce the risk of human error and improve electrical safety. Finally, it's important to remember that electrical safety is an ongoing process. It requires constant vigilance, continuous improvement, and a commitment to learning from our mistakes. By staying informed about the latest safety standards and best practices, and by continuously evaluating and improving our safety programs, we can create a safer working environment for everyone.